Hi, everyone. Welcome to this joint seminar that we're holding between the CAFE and CASH projects, two different National Institutes of Health funded research projects that look at the relationship between climate, extreme weather events, and health and aging. Today, we have a collection of our joint efforts from representing various individuals. You're going to hear from a bunch of us, myself, Josh, Kevin, Amy, and Jenna, and we represent together a collection of individuals at public and private universities throughout the East Coast. You all came to learn something about GitHub, so we're just going to get started. Next slide, please, Kevin. Kevin and I will each introduce the CAFE and CASH projects, and then Josh is going to give us a GitHub 101 tutorial. And then Jenna Topoldo and Amy Reed are going to give us GitHub challenges and considerations from a novice or newish and a more intermediate user of GitHub, and then we'll have some Q&A at the very end. So so thanks for being with us. Just very briefly about that, CASH is the Center for Aging, Climate, and Health. It's a collection of universities that have come together. It's a virtual center, so and it aims to reduce the barriers to sort of entry into the to the study of at the intersection of aging, climate, and health, and with the intention of improving the understanding of public health consequences of environmental conditions and challenges in the 21st century. We focus on the health of older adults. And we're a hub for sharing code and other resources and seminars and community buildings. And we also facilitate research through pilot projects and seed grants. So we have a newsletter that you can click that. You can take a picture of that code if you want, or agingclimatehealth.org. Next slide, Kevin, please. And if you're looking for data and code, in this slide deck, you can click on this. There's a direct link to some data and code. Just a pause for that. What we're doing, CAFE has, as you'll hear about, they have a really much more, they have a much larger collection and a more nuanced structure for their GitHub resources. And we hope we will be partnering with them in the future so that if you're looking for stuff on aging, you can find us a little bit through them at the intersection of aging, climate, and health. And if you're looking for stuff on, and our resources will point to their resources as well. So there'll be greater collaboration. Look for that coming soon. We have a series, What Am I Reading? Please go ahead and check it out. Learn about our demonstration projects. We have run seminars, and join our newsletter. I'm passing it on to you, Kevin.
Thanks a lot. And for those that are new to CAFE, I know some people have joined and been part of our community of practice for a while, but I just want to briefly explain what CAFE does before I turn things over to Josh and the team to be able to go through the GitHub. So for those who are unaware, my name is Kevin Lane. I'm an associate professor at the Boston University School of Public Health, and I also co-lead the data management function on the CAFE community of practice with Danielle Braun from the Harvard School of Public Health. Josh works with us on the data management side from IQSS and is really an expert in things related to metadata intersections between working within public health and other data systems. So it was really great to have Josh on our team who helped build our initial GitHub platform. And what CAFE does, we really seek to help provide a platform and ecosystem for researchers to convene, accelerate, foster, and expand that extreme weather and climate health community of practice overall. In terms of what CAFE provides, we also have a QR code here. If you're new to the team or if you're new to our community of practice, you can join our newsletter as well. We provide a whole host of different offerings for you to be able to work with CAFE and to collaborate in other ways. Additionally, we have a series of data and data management resources that I co-lead and that we oversee, and we're going to be talking about today. Specifically, what the CAFE data management provides is we have a facilitated and sharing approach by utilizing Harvard Dataverse, where we have a collection of health and extreme weather data sets that have been posted. We're just coming up, or just past maybe yesterday, 1,000 data sets that are available for people to use. And what we're going to be talking about today that I'm excited about is some of the work that we've been doing in terms of promoting data science and software tools to enhance and harmonize processing, linking, and analyzing of climate-related common data sets within GitHub overall. And really to help set the stage as to why we're talking about GitHub as well before I turn it over is really embedded in that fair data principles, which is at the core of what CAFE and Cache are trying to do, where we're trying to make your work more findable, accessible, interoperable, and reusable. And GitHub is really at that central point, both in terms of providing findable, but linking all the way into to reusable as well. So putting your data sets into repositories so that they can be found, whether that's going to be in something like Figshare or Dataverse, but then also providing code and opportunities for people to be able to integrate that in. And GitHub is a nice resource for that help promote the reuse of your data set with other potential cohorts, health studies, or applications overall. Additionally, we might talk a little bit about the data management sharing plan idea, which is an essential part of NIH now, beginning in January of 2023 with new grants, needing to be able to provide data that can be non-HIPAA related shareable, but also providing the tool software so that your code that's being generated from projects can be reusable as well. So there's different applications in terms of repositories and GitHub that can be used to help fulfill those data management sharing plan needs. Additionally, we have an excellent, if you're interested in the data management sharing side, we have an excellent presentation done by a professional librarian from the Harvard School of Public Health that went through an hour explaining sort of the needs of a data management sharing plan within NIH and how different repositories and other resources can be used to help meet those needs. Any of these resources, including the webinar today, can be found through our website and go into the educational resources as well. Some of the benefits of using GitHub to help meet those standards and fall into fair data principles is really that idea of having persistent identifiers, open accessible data. That's something that GitHub does right from the default. Being able to match these different Gits together and then making them operable. You can have standard code formats and reusable promotion of data science to meet those fair data principles on which CAFE, Cache, and other NIH initiatives are based. I'm going to turn it back to you, Deborah.
I
Deborah,
think we are well, I think I'll do the DOI slide at the very, very end after everybody
okay,
else.
you
So,
got it. Then let me
so
turn it over
yeah,
to
let's go
Josh.
to Josh. Yeah.
All right. Thanks, everybody. Can you guys hear me okay? Does that sound all right?
Yep.
Okay, perfect. Let me just go ahead and pull this up. And then do a share. All right. How does that look?
Great. We can see it, Josh. You're all set.
Perfect. All right. So, as Kevin said, my name is Josh Cetron. I'm a data science specialist at Harvard's Institute for Quantitative Social Science, or IQSS, and I work on the data management function as well with Kevin for CAFE. My background is in research analysis. I did my PhD in psychology and neuroscience, and then came up in the world of statistics from there, and have been lucky enough to interact on a couple different kinds of fronts, working on data science and data analysis for a lot of different sort of genres of research, a lot of different fields. And so from that vantage point, although I would not consider myself to be like a hardcore, GitHub everyday user expert, I didn't come up in software engineering where you often see people using GitHub heavily come from. My vantage point on GitHub is as a research scientist, and so I'm trying to give this introduction at the level very generically of folks who are doing research, doing analysis, want to share their code somewhere, want to learn more about how to do open source coding and open science through GitHub. And so I'm going to give that kind of high level introduction. I have sort of one quick example built into this from some of my own code that's on GitHub. And then I'll turn it over to some the rest of the team to give some more details on a few specific things that might be more relevant for the audience and your field in particular. So what is GitHub as a first pass? It's worth clarifying this because I think people take for granted that people know what GitHub is. So GitHub is a cloud-based platform. In other words, it lives on the internet, a website where you can host your code so that others can see it. They can replicate it easily with attribution built in, and they can collaborate on it And I should note that collaboration in the GitHub context is always subject to permissions-based approvals. So if you're the owner of a repository, you're the person who is managing it, whether or not other people collaborate and how is up to you. And I'll talk a lot about what the mechanisms for collaboration are that are built in. What is GitHub for? And maybe it's helpful to clarify also what it isn't for or what it isn't optimized for. So GitHub is really designed for active development. It came from the world of software engineers who wanted to do open development, and open meaning transparent, so that everything that's being done is in the view of others. They can comment on it and contribute to it if they would like, or if you would like them to, and it helps things grow from the community perspective up. GitHub is, in that spirit, optimized for sharing living code, so ongoing analysis. It's optimized for version control. In fact, it's built on a platform called Git, which is specifically a version control software. I'll talk about that a little bit more in a bit. And it's optimized for a series of techniques for collaborative coding, in particular, working on the same project with other people at the same time, so in parallel. One of the really useful tools that GitHub has for doing this is something called branching, and we'll talk more about what that is in a bit. But these are the kinds of things that if you are writing code for your analysis and you think, oh, I might be interested in using GitHub, that this is the sort of optimal space to be deploying the tools in. And I should note, I won't be able to keep an eye on the Q&A, so I'll try to stop periodically and check. But if there's something that comes up that one of the other panelists can flag me to, please feel free to interrupt. Okay, so these are things that GitHub is great for. What is GitHub not so great for? GitHub is not so great for what we might call archival code, stable versions that are associated with specific things. So for example, if you write a paper and you publish that paper and you have analysis code you want to share, that analysis code may not change because you want the version of it to be stable and associated with the paper. You can certainly upload that code to GitHub, but there are other platforms that are really more specialized for archive and access to archival data with things like comprehensive metadata. A sneak peek is that one of those is Harvard Dataverse, and CAFE and Dataverse have a lot of great resources for how to upload both data and code to repositories like the Dataverse platform. Similarly, data sets and especially large data are not things that will go on GitHub by and large. So GitHub does not have a lot of storage space for the things that you want to upload. They are a cloud-based platform that's mostly trafficking in text files and code scripts that are pretty small. And so they're really not built for you to put a lot of data up to work with. One thing to note about that is when you're writing your analysis code that's interfacing with data, when you want to make the code public on GitHub and for people to be able to interact with, you have to make sure that the data is also somewhere accessible, easy to download, and easy to run with and link up with your code. That platform is not likely to be GitHub, so looking at platforms like Dataverse is a great way to make sure that everything you're doing is accessible. And lastly, GitHub is not designed for sensitive information. So there are both private and public repositories on GitHub, and I'll talk a little bit about how that works. But even if you have a private repository in a platform that's optimized for collaboration, you should always assume, especially anything that's on the internet, that there's a chance that it could become public, and you should never put anything in a GitHub repository that shouldn't become public. So that includes any protected information about participants, protected health information, and of course also things like passwords, API keys, and personal access tokens, things that you might use in your scripts to access websites and code and data in your code, but that you want to make sure when you share that code is removed from there with a placeholder that other people can put their own personal access information in instead. So never put passwords on GitHub. Okay. So I want to talk a little bit about where GitHub falls within what I refer to here as the open science workflow. Really, this is just the research workflow, but with a lens that's applied to open science and sharing your process and your data and your results. So in a timeline that runs from kind of the beginning of project design through data collection, data preprocessing, data analysis, and then ultimately distribution and sharing, we would start off with the initial design with a different set of tools, right? So you might, in your planning for your project, you say, okay, I know I want to do this in an open-facing kind of way. I want to make sure things are transparent and accessible. I'm going to create, at the beginning, an all-purpose kind of repository project page somewhere online where I can eventually deposit materials and other things that people will be able to access. So GitHub is not really designed for that, but there are other tools, things like the Open Science Framework or OSF has project pages that you can use for this sort of purpose. You could create that at the beginning of your workflow. You wouldn't necessarily populate it with anything right away, but just so that you have it in place. And one of the first things then that you might put in there, if you're sort of targeting this open science workflow, might be a pre-registration. So OSF and other tools also have ways of creating pre-registrations for your study. We're obviously not going to talk about that today, but this is another sort of material in the workflow that might go somewhere on the internet where people eventually can access it. Eventually, you're going to move into data collection. And once you start collecting data, you're going to do your data cleaning and de-identification process. Depending on the kind of research you do, this could look different for everybody, of course. This process is usually part of the workflow. And one thing that I wanted to point out here is that this is not really a GitHub-oriented process. So because when you bring in your raw data, especially if it contains any kind of sensitive information, identifying information, you're not going to want that to be shared with the public. That's a process that you're going to do in your own way, whatever way is compliant with your IRB, whatever your lab protocols are. So you might get in your raw data, have it on your lab server that's secure and protected, do your de-identification process, do your cleaning, get your tabular data out of that. And then what you get out of that, you can start to work with in other contexts, and you can then be developing your analysis on top of that. So that's something that's going to happen away from GitHub, most likely. And then, of course, you could say upload your survey materials to something like your OSF project page, these other pieces that are not part of your code workflow. Now, finally, we move into data analysis. We're in GitHub world. So in the data analysis process, you could start by just creating a GitHub repository. You could make it private initially and then translate it to public later, or you could have it be public from the start. And in that space, you're going to actually develop your code. And when you do that, you're going to be working between the sort of GitHub location of your code and what are called remotes or local access points that you can install and create in lots of different places, wherever you basically do your normal analysis. So what's going to be happening is you're going to be doing your analysis as you normally would in the location that you would normally work, but it's going to be linked to your GitHub origin location, the GitHub repository on the internet, and periodically you'll make updates that get translated to that sort of main location in the cloud. And syncing between those things is precisely where GitHub excels, so that you can have something you work on your own, but then it gets translated back to something that everyone can access. So that's where the GitHub workflow is going to concentrate. We're going to zoom in on that in a second. Ultimately, when you're ready to distribute and share everything, you can obviously share your GitHub repository itself. It's a public repository. You can share it however you like. You can also share your data and archival code, as we discussed on a platform like Dataverse. You can share your written materials, maybe a preprint, maybe a publication, and you can link all of these things together. So you can make sure that people know that if you look on Dataverse at our entry, there's archival versions of this code. It's linked to this sort of context, but here's a live link that takes you to our GitHub repository where we continue to develop the program, or we continue to develop the code, and you can see what we're up to now. And those things can then live simultaneously, one in a kind of archival format and one in real time. There are more complex ways that you could choose to handle this. This is just one, but in the interest of time and keeping things at the high level, I'm not going to get into the weeds unless people have specific questions. Okay, so hopefully this gives you a nice overview, and we're about to zoom in a little bit. But before we do that, I just wanted to acknowledge something that I think is probably on a lot of people's minds, which is open source coding can be a little scary if you haven't done it before, right? And I think what's intimidating about it for a lot of people, myself included, is that this information. So this is a preview of what the public view of my GitHub profile looks like. I cherry picked a section of time where I was particularly active on GitHub. If you were to look at it now, it looks much more empty, which is how you know I'm not really an everyday user. But the point being that all these activities that I'm doing are viewable to the public, and same with all of these changes that I might be making. You can zoom in on any one of these things. This is a preview of an application called GitHub Desktop I'm going to talk about a little bit more. You can preview any of the changes that I made in this sort of line-by-line way, but there's a lot of those, and realistically, most people are not going to be going down and looking for errors in every single entry that I've ever made. So some of this intimidation factor is just, oh my gosh, is everybody going to be looking at everything I'm doing? And some of it is more about, well, maybe I have a way that I like to work and I'm not ready for it to be seen by other people in general until it reaches a certain point. There's ways of handling all of that. So you can still do most of your development work in the usual way that you would do it, right? You can work on things in your local machine, you can get everything tidy and ready to go, and then when you're ready, you can push your changes up to the main repository. And you can also develop in a private repository and then make it public later. One thing to note about that is by default, the history of changes you make, what's called the commit history, will also be made public when you make the repository public. Again, the likelihood of people digging into the details on this just to hunt down mistakes is very low. I liken it to kind of like having the peer review history on a paper published with names attached and so on. So, you get to see, if you'd like, what the working flow and workflow process was like, and you can understand with the context of how certain decisions were made. But it's not there just to expose people. It's there really to give insight. And in fact, the origin or the original spirit of this style of programming, this open source style, is so that it makes it much faster actually to figure out if something's wrong, what it is that's wrong, and track it down and identify how to fix it. So if I've made a mistake, I'll give you an example. I was using an R package for a CAFE project where one of the pieces of, it was for web scraping, one of the pieces of code was scraping the email URLs incorrectly. It was limiting the number of characters in a way that it didn't need to. And it was causing us to miss certain emails that we were trying to scrape so we could send out a survey to people. And so I was able to go into the code, find exactly that was the problem, and not just have to be like, it's broken. Why is it broken? I could go in, look in to see where I was running into problems, find the line of code and where it was written, and identify that it was a problem. I could contact the person who maintains the package and say, hey, I noticed there was an issue with this. I can open an issue. They can see it. And if they're active and they're maintaining the package, they'll respond and say, great. And he made the change, or she made the change, and they were able to update it within a day, and I could get the package up and running the way that I wanted it to be. So, and if not, there are other ways that I could have handled the situation. I could use another tool that GitHub has called forking. I could make a duplicate of the repository for myself, make the change on my own, and use it on my own. So there's lots of really useful benefits to having things be this transparent, even if it's a little uncomfortable at first to get used to the workflow. Okay. I'm trying to keep an eye on the Q&A, but it looks like we can keep going. All right, so this is a very overwhelming and dense slide with lots of words. Hopefully, the purpose of writing it this way was that hopefully people can return to this and revisit it as needed. But I wanted to go over some of the GitHub jargon because I think this is another thing that can be intimidating. And often people will use these words with the expectation that other people know what they mean and not necessarily go through the process of explaining. There are great tutorials online and other things that you can look up that will also explain these things. These are my definitions that I wrote myself based on my experience working with them. If there are better ones out there, please defer to those. But for the purposes of not feeling scared of these words or not worrying about whether you understand them correctly, I will briefly and quickly go through the ones on this list and hopefully not take too much of my time doing that. So the first thing, which I alluded to earlier, is that Git, in fact, is not the same thing as GitHub. So GitHub is a commercial platform that was created to leverage the tool Git in a cloud-based infrastructure. But Git, in fact, is just a version control software. And so there are other ways you might encounter it. Some labs, in fact, in mine in grad school, we used Git internally between our local machines and a server to manage changes between those things. So for advanced users, there's a lot that can be done with Git that extends beyond GitHub. When you're in GitHub or just using Git, you have the sort of primary working location is your repository, or often called a repo. You might hear me say both. A repository, a repo is a special type of folder. It's been set up to host all of the files and materials for your project. And specifically, it's been linked to a special type of infrastructure under the hood that allows it to be accessed through the Git version control software. The main location is called the origin. So in your case, this is going to be the location that lives on GitHub. And then you can create what are called remotes, remote locations, which you can work on at any point. So I might have a remote on my local computer or on a server somewhere. I work on my analysis, and then I communicate between the remote and the origin using GitHub's tools. READMEs are something you're probably familiar with from other contexts. A README is a crucial document in GitHub in particular, which is used to explain the contents of a repo. And specifically, the user creates this using the name readme.md, which is a markdown file. And then it's automatically detected by GitHub and displayed on the page, on the web page, which is really, really handy because it means anytime you have a new folder that somebody navigates into, you can create a README so that it immediately is explained. It's always, always, always essential to have good READMEs. It makes your code so much more interactable and interoperable. And it also basically takes your code from being just a bundle of files that someone has to sort through to being an organized series of materials that, in essence, is a kind of tutorial for how to do what you did. So I consider these to be really essential. There are other ways to label what you're doing in GitHub, but this is the easiest and most critical, I think. Now we come to a series of words for operations: fetch, pull, stage, commit, push. You've probably heard some of these if you've looked into GitHub at all. These are all ways that you keep your remote and origin locations for your repository in sync, and they track changes along the way. So if you're working on a remote location, you fetch in new changes to see what they are from their origin. You pull them into your working directory. That's actually getting them and putting them into your local location. Then you make whatever changes you're going to make. You stage them to prepare them to be sent off. You commit them with a message that says what they are, and then you push them back to origin. So that's that workflow we're going to talk about over and over and over again. That's the basic workflow of how to use GitHub. Yes, I can make sure that these slides are available through whatever means they're usually distributed. I'm not sure, Kevin, but you can maybe comment on that later. But yeah, I'll make sure people have access to this. Branching, merging, these are tools I mentioned a little bit earlier for keeping the development, especially the collaborative development process, neat, especially when there are multiple people working together. So a branch is a parallel version of a repository's information that you can develop on separately, very safely. It doesn't interact with or interfere with the main branch at all. You can work on it to develop new features or to work on a problem, or even just as your main way of adding to the repository in your development. And then when you're ready to bring those changes into the main branch, you merge them together. And that merge process, if there are conflicts, it will point them out and you can resolve the conflicts. Cloning and forking are also probably words you've heard, but maybe don't know exactly what they mean. So cloning is a way of duplicating a repository for development as a local remote, and you can then either just keep it separate on your own and just local, or you can communicate back to the original repository if you have permissions. Forking is a process of duplicating a repository as it's sort of a save as new, right? So you create your own version of something. It preserves the history of everything that came before it, but it's now yours and you can develop on it and make changes in a way that you wouldn't be able to if you didn't have permission, say, to change the original version. So for example, I have a personal website that I've created through GitHub, through their GitHub Pages software. And for the template of it, I forked a repository where the template had already been created. And then I changed it to become my own. These are both, I think, tools for working with the contents of a repository in locations other than the host, other than the remote or the origin. And then finally, we have issues and pull requests. These are ways to collaborate either with specific individuals on your team or with the broader community. Issues can be opened by anybody who can view the repository, and then you can respond to them either with sort of a back and forth or with new code and resolve and close those issues. And then pull requests are ways that people can propose new features, whether that's you or somebody on your team or somebody else that has the permissions to create this. They basically propose new code to be integrated, and then you can go through a review and approval process to bring that code in if you like. Okay, that was a ton of stuff on one really big slide. I'm going to take a quick second to make sure that there aren't any questions about any of these, and then we can go on into the workflow a little bit more. I should also say this is not an exhaustive list of GitHub terminology, and I'm sure there's also ways people use some of these terms that are maybe different from the way I do, but I think of these as kind of the essentials. Okay. All right, well, I'll keep on moving because I know there's other stuff we got to get to, but I'll keep an eye out for some questions. So with this as the backdrop, how does this all fit together into a workflow for somebody who's doing their analysis programming as a researcher? So first thing you're going to do in your GitHub workflow is create a GitHub account. If you don't, we're going to start very simple basics. If you don't have an account already, you need to make one. GitHub, as I said, is this commercial platform. And so to use GitHub specifically, you need an account there. It's free. If necessary, if you're working with an organization, so CAFE, for example, has a GitHub organizational account. It can be a useful way to have multiple people with different roles be assigned into those roles and work together. So you might have an administrator, then you might have collaborators and other kinds of managers with special account privileges. And then when you're developing together, it's clear who can do what. So that's the first thing you'll do. Then you'll create a repository for your project. So this gets initialized with a name. That name has to be URL friendly, so no spaces. Usually it's separations are hyphens or underscores. Hyphens is more typical for GitHub. A name that's specific to what the code that's in that repository is. A README, as we discussed. A description in addition to the README, and I'll show you kind of where that is on the page. That's just a web description that can be typed into a little box if you're creating a repository on GitHub. And then a license. We haven't really talked about this yet, but when you're sharing things freely, there are ways to impose certain kinds of rules on how you want the materials to be shared, and that's through licenses. Usually on GitHub, you see things like the Creative Commons licenses or maybe the MIT license. You should take a look at the options and make sure you choose the one that makes the most sense for your reuse context, for what you prefer, for what's appropriate for your work. An advanced detail that I'm not going to cover is what's called a git ignore file. Basically, it's a way of making sure certain kinds of files, especially junk files and temporary files, are not uploaded when you make changes. But that's not for that's for once you're comfortable with the context of a GitHub repository and workflow. Okay. You make your repository. Now, it only exists on GitHub. You probably want to do your analysis somewhere else. You can, in fact, develop on GitHub. There's a way to edit code in the browser, but you probably have a workflow that works for you. So you want to clone that repository to your local machine. And since you are the owner of the account, you'll have all the permissions you need to be able to work on your local machine and push and pull changes back and forth with the origin. That might be your laptop, that might be your work PC, that might be a server that you work on where things are housed for your lab. Wherever your primary development location is, that's where you're going to clone the repository to, so you have a remote there. Then you're going to populate the repository with your code. So there's a bunch of ways you could do this. The first option, which I think is going to apply to many people, especially when you're in the first stage as a researcher of trying to just get your code out there somewhere that people can access it, is you probably have existing code that you've already worked on. It's already up and running the way you want it. And you just want to get it somewhere where people can see it. And putting it in GitHub is a great way to do that. In that situation, you would clone the repository, so you have an empty folder on your computer. And then you would take your analysis code and just copy and paste it. Just move it right into the repository, and then push those changes up. And what will happen is your changes will all come through as sort of one big change to the repository's origin location. And you'll see, oh, great, everything is there. And then any changes you make from then on will be these iterative changes on the materials that exist there. So that's option one, and that's perfectly fine. And a lot of people still prefer to do that, even if they're already comfortable with GitHub, because it's easier for them to work in their offline location to get the kind of first draft of everything up and ready to go. Another option, though, is that you can basically start the process much earlier in your sort of research timeline, and you can begin coding within this empty repository and just push as you go. So you can say, rather than copying and pasting existing code, I'm going to just open all my new files in this location on my computer, do all my work here, and then eventually, when I'm ready, I'll send those changes up to the GitHub origin location, and then we'll continue to work in that way. The upsides of this workflow, in addition to being more transparent, is that you don't have this like vestigial, previous version somewhere on your computer of your analysis that's not in a GitHub repository. So there's no confusion about where you should be developing. And that's something you always want to avoid in general. And with, something like version control that's built into GitHub, it's really great to be able to make use of those tools and not have to worry about that other problem. And then you're just going to do what we discussed. You're going to fetch from origin, you're going to pull in changes from the origin, you're going to edit your code, you're going to save things. When you save them, you're going to stage those changes, and then you're going to commit them, and you're going to push them back up, and you're going to repeat this as many times as necessary. And I'll show you an example, a very simple example of what that looks like. So this is basically it. This is pretty much the workflow. And it can obviously get much more complicated than this for people who are doing complex collaboration and are really doing software development. But for researchers, I think this is like a very good, solid starting point for how to use GitHub. A couple important notes, and I think these will probably get hit a few times. First of all, as I said already, nothing private or sensitive should ever go in your repository. Just going to say it again because it's important to know. And you will not have space for data, just your code. So make sure your data are accessible somewhere else where you can reproduce the code by accessing the data from that location as well. I alluded to a programming language called Markdown. It's really sort of a syntax of mostly plain text. It's worth familiarizing yourself if you haven't previously with Markdown. Markdown is used for READMEs and also for other advanced things. It's basically a shortcut language for rendering simple HTML text. And so the formatting is easy to do. It's very intuitive to use. I find it extremely handy. I often take notes in Markdown. I highly encourage people to get familiar with Markdown. And there's a sort of version of it called GitHub flavored Markdown. If you ever see that, that's basically the one that's used by GitHub. But they're all very similar. And lastly, when you're developing, you can choose your favorite way you want to manage your sort of remote locations. You can integrate GitHub directly into most interactive development environments. That's things like RStudio, VS Code, whatever your preferred developing environment is. Almost all of them, I mean, in this day and age, all of them have GitHub integrations. And so it's very easy to set that up once you have a GitHub account. You can also manage those things with a platform I showed you a sneak peek of before called GitHub Desktop. That's produced by GitHub. It's free also, and it allows you to manage and sync changes between remote locations and your origin without having to worry about integrating into your programming platform. And then you can develop directly in the browser. You can actually edit code right in your on the GitHub website when you're logged in. So these are all options for how you can work. Okay, before I run through a quick example, first of all, am I doing okay on time? Do I need to accelerate things? And then also I can peek it for questions.
I think if you have about 5 more minutes, Josh.
Okay, perfect. That should be fine. All right, I'll jump through this quickly and then we can turn it over. So this is an example of a commit. So that's a change that's labeled, that's pushed up to an origin location. So it's sort of a silly example, but as I mentioned, I have a personal website that's through GitHub. Here's what that page looks like. If you go to my GitHub and open the repository for the website, you'll notice that it's forked from a template. This is the Jekyll template by somebody named Barry Clark. And then I've made my own changes, etc. Pay no attention to the timestamps on this page because obviously I took this screenshot late, but we're going to zero in on the 404 page, which would be the not found error page that comes up if you try to go to a page on the website that doesn't exist. It says it was updated 3 minutes ago, but that's because I took this after I already did the update. So normally this would say whenever the last time was that this was changed, that's what what this column is showing you. And then this is the commit message, the thing that was done in that last change. So the fact that it says update this is because I did it in the wrong order. But let's pretend this isn't here right now. We're going to make a change to that page. So if I open up my remote location, this is an example of Visual Studio Code, VS Code, of how I might edit something in that repository on my local machine. So I'm in my local remote here, and it's synced, of course, but I've made some changes. And so now I added onto the page here a little haiku, and I want to make that part of my website now. So I've made these changes already. I've saved them. You can see the changes that are made are indicated with this little green bar. It's brighter until you stage them. So I saved them and then I staged them over here. This is all sort of point and click within VS Code. And I'm in the what's called source control or version control tab. So you can see the history of all the other updates that I've made as well, syncing between the remote and the origin or master or main branch. Master or main branch, the origin location. So I want to push these changes. I'm happy with it. I can go through a process within VS Code to do that. So I can click this little commit button here. It'll prompt me to enter a commit message, and then I can push the changes once I approve them. Or let's say I didn't have this all set up. I might instead use GitHub Desktop. This is a separate application. It knows that I've made a change in this repository. It can actually see what they are. The same changes are listed here, and I could commit the changes through this platform. I would only want to do one of these, obviously. It's better not to have multiple ways of doing it running together, but let's say this is my preferred method. Then I would write my the name of my update here. It defaults to just update and then the file name, a description, and then I can commit and push it from there. And this has also sort of point and click buttons for fetching from the origin, changing your branch, et cetera, et cetera. So, all right, I made my changes. Let's say I committed and pushed them. They're back up on the server. When I go back to GitHub now, if I look at the commit history, I can see, hey, I added this new commit, 404 haiku. And if I were to click on this, it would show me the details of that commit. It looks basically the same as what it looks like on the other side, right? You can see these green plus signs are things that were added. If I had changed anything, they would be red minus signs. And this sort of +6 is how many lines were added. So 6 lines added, 0 lines removed. Great, everything looks good. Because this is on my website, I then might want to go and see how it looks. So I go and preview it. And it looks pretty good. It's there, but I noticed, oh no, it's all in one line. I actually wanted this to be in multiple lines. So there's a little funny trick, which I'm using this as an opportunity to point out in Markdown, where if you want to automatically make there be line breaks, you need to do 2 spaces at the end of a line, and then it will actually bracket them out into line breaks, return characters. So, okay, all right, I made a mistake. I don't really want to go through the whole process of opening it up on my computer and doing all that again if it's a really simple change like this. I mean, I could have done this for the other one too. So I'm going to go in and edit it directly on the GitHub website. This is what that looks like. There's a little button that I didn't show you before up here, but it's an edit button. And then I can go in and actually just edit the code directly. So I can add these extra line spaces here. When I commit those changes, it's with this green button here. Gives me the same kind of interface. You know, everything is really nice and consistent of how it looks to do this. Give the title. I say in my extended description that I fixed the spacing. In this case, I'm going to commit directly to the master branch. The sort of best practice is actually to develop in a new branch and then merge the branch back so that you always kind of preserve the main branch as just everything that you're happy with, and anything that's in progress is somewhere else. But for a simple thing like this, I'm just going to commit it directly, click commit changes, and then they get updated. Here's my new commit here, update 404. Voila, everything looks great now. So I know that was a really sort of silly example, but it gives you a sense of what that workflow looks like. And when you're doing this with your real code, your analysis code, then you'll get used to that, I think, pretty quickly once you start doing it. The workflow always looks something like that for the bulk of what you're doing on GitHub. Okay, really quickly, I have a couple best practices and then preview some advanced things, and then I'm done. So I already mentioned including a README. I just mentioned using development branches, pull requests, and reviews for collaboration. This is an infrastructure that's really useful that I'm not going to have time to explain. Topic tags are within the GitHub website and web interface, so you can search for repositories by name, but if you include little topic tags, it becomes much easier to find your repository if somebody searches for similar things. We have a climate-cafe topic tag you can use to find the cafe repositories easily. And then the last thing is always troubleshoot your materials across a variety of locations. The reason you're sharing things on GitHub so that other people can download and use them themselves, and you want to make sure that it's probably going to work for them. So if you can, don't just run it on your machine, push it to GitHub and be done. Try to have somebody else pull it down and test it on their own machine, or do it on another location. And then you'll be more likely to catch things that aren't going to work. Yes, and they're putting together a cache tag as well. And then a couple things just to, keep you interested in GitHub. I mentioned git ignores, managing junk and temporary files. There's also more to say about forks and replication and how the attribution works. There are command line interfaces. So if you're somebody who works a lot in the terminal, it's really great to be able to use everything you need to do with GitHub and with Git in the command line. But obviously that's for advanced users. GitHub Pages is the way that I have that website set up. That's a free service that anybody can use for things like blogs, personal sites, documentation. And then, of course, there's GitHub Copilot, which is the sort of AI coding assistant. It's really powerful. People have lots of opinions about how it works in their workflow, but that's a service that's part of the GitHub ecosystem. It's part of their commercial system. It doesn't really have anything to do with Git or anything we talked about today. So I mostly mentioned it to differentiate those things so that people don't confuse them. Okay, I know that was longer than I was supposed to have, but that's what I've got. And I'll be happy to take some more questions too once other people have a chance.
Yeah. Thanks, Josh. I think I'm going to be turning it over to Amy and Jenna now at this point.
Hi, everyone. So I'm Jenna. I am a PhD candidate at CUNY-SPH, and I'm a beginner in GitHub. So I am also learning. Was learning a lot from Josh. I'm excited to try a lot of those tips. I've so far been working in GitHub on the web interface, so I'm excited to try the desktop. I'm an R programmer, so I'm excited to integrate it into RStudio, and I've also dabbled in Python, so excited to see how it works with VS Code as well. So the first thing I wanted to start with is like GitHub has a lot of resources. So in addition to all of the resources that we're sharing here today, in addition to that awesome dictionary that Josh gave us with his own definitions, GitHub also has a glossary. So there's a lot more terms in here than what we just mentioned. So feel free if you come across a term to take a look at that. But they have a lot of resources. You can see them kind of outlined here on the left, like talking about types of GitHub accounts, like if you're working in an organization or an institution, learning to code, accessibility, writing on GitHub, and then they have resources on basics. They also have interactive tutorials, and this is how I've started like getting myself familiar with GitHub. Oops, did I stop sharing screen? Yes, I did. No? Okay, somehow I got out of my PowerPoint. Let's see. Okay, I'm back. Sorry, Zoom is confusing sometimes. Yes, okay. I have started by working on the skills. They're interactive courses to learn GitHub. When you work on it, it actually, you go into the website, they have some courses that they recommend your first day on GitHub to do this intro to GitHub, and then there's a few others. So when you start this course, it's actually going to have you clone a repository. So it's going to encourage you to make it on your own page. And then it's going to walk you through step by step how to like work on GitHub. And it's guided by a bot. So you'll see that there's like kind of like a comment on your page that says, hey, welcome to your skills exercise. And it'll give you step-by-step instructions, and then you do something, and then when you push, for example, you'll refresh the page, and then it'll tell you the next steps to do. So it's really helpful, and if you run into issues, it'll give you feedback on what you could do better. It also links to like Q&A section. So it's really helpful if you're very first starting out as well and want something that's kind of interactive. So on GitHub, you can also customize your profile. So this is on your own page, you can add an image. You can also use this markdown language to create a README on your own profile page to say like, I'm working on my dissertation. What am I learning? How to reach me, etc. I also started off by creating a repository. So I took some of the code that I had developed for our CAFE workshop that we ran at PAA in April. And I created a kind of vignette of that code and just uploaded it to try to see if I could create my first repository. Again, I've mostly been working on the web. You can go and check this out yourself if you want. So I got practice in like choosing a license. I chose the MIT license. I got practice in writing a good README. So I wrote about how this code analyzes publicly available data from the Sheldis dataset, which is a disaster dataset. And I gave some links. I gave a lot of tried to give a lot of detailed information about the dataset and how the code works, what packages I'm using, etc. And then you can see that I have updated that code as well. So when I uploaded this code and tried to edit the code, I initially wrote this code on my local machine, and then I put it on GitHub, and then I tried editing it in a few different ways. So one way I edited it was I edited it on my machine, and then GitHub, if you're using it on the web, allows you to upload a new code file to replace the old, and it compares changes between the two. And then, like Josh mentioned, you can also edit directly in GitHub Web so that you can, for example, I added a description to this line of code. And it also, when you look at the code, if you look at the blame tab, you can see like when certain lines of the code were updated. So that's about all I have. And I'm going to pass it to Amy, who is an intermediate user.
Right. Let me get my screen shared. Hi, everyone. I'm Amy. I'm a PhD candidate in sociology at Princeton. I do feel like intermediate is a little bit higher than where I'd put myself. I've been using Git for maybe a year now at this point. So some of the things I'm going to talk about today are stuff that I'm still working on learning and implementing better myself. But I'm calling this good practices for GitHub because there's not just one way to do everything, and different groups you might work with will have different conventions or different ways of doing things. So these aren't necessarily best practices, like you have to do them this way, but they're things that people told me when I was starting out that have been super helpful. So um, 5 things I want to cover first, and Josh and Jenna covered some of this already, so I'll go kind of quickly through some of it. But number one is definitely having clear documentation and descriptive names. I think you've heard this before as far as like file names, variable names, and inline comments, but this extends to when you're adding a commit to Git, make sure that you're putting a good description of what you did, because that is what you're going to see when you try to go back and figure out where something broke and when it broke and who broke it. You're going to be relying on those comments that show what was in each commit. And so you want those to be incremental and describe what's in them. So you're not having to scroll through, 50 different things that say updated cleaning.do. So if you use comments like that, make sure you put something in the longer description to describe what changed so you can go back and find those later. And then the README, I have a slide on that later to kind of talk about what should go into those. But rule of thumb is you probably aren't putting too much information in there. A lot of people err on the side of putting too little rather than too much. So if it seems relevant, it probably is at some point, either for your future self or someone using this code. So just throw it in because you never know what you'll forget. And then second, kind of along with this, as far as syntax and formatting, there's all kinds of rules of thought about, like camel case versus snake case and variable name conventions. And I would say it matters less what specific rules you use than that you pick something and are consistent with it, because that's going to make it a lot easier for someone going through your projects or you going through your own projects to figure out what you did and why. So if you're working with a collaboration group on something, collaborative research project, have that discussion up front, decide how you're going to name things, how you're going to organize and format stuff, and then just stick with it. And then the third thing would be, this is one that I am struggling to implement in my own research because I have very different habits. But short and modular scripts are going to be easier to work with than longer ones. So I got in the habit of having like one script for everything that I do for cleaning and one script for everything I do for analysis. And that sounds great and it sounds organized, but then trying to go back and scroll through some really long script to figure out what needs to change or which pieces you need to copy and paste into a similar but different project, just it vastly introduces the potential for errors. So a better option would be to try to use short modular scripts. So have, one script for cleaning one specific data set that you use all the time, a separate one for cleaning a different data set that you might want to merge with the first one, and then a third script for merging them together. And then you can organize those in folders. Like Josh mentioned, have a README for that folder explaining which ones to clean in which order and how to merge them. But then in future, if you want to use one of those data sets and not the other, you can just grab that cleaning script from the first one and just use that script as is without copying and pasting stuff and potentially like introducing errors in there somewhere. And then Josh mentioned this already too, but Git is not a file storage system. So if you're like one thing I'll do pretty often, because a lot of the data I work with is census data, I'll just use the API to grab it rather than downloading files from data.census.gov. So when I'm doing that, like I'll have code that does that for me. So then I'm not tracking those data files with Git. Those are in a folder that I've used the .gitignore file to tell Git, don't track the data file folder or anything in it. And then the code that I write will pull the data from the census and create those data files that I'll be using for my analysis and store them in those folder, but none of that is tracked on Git, just the code that I'm using to do that. And then last thing is just get in the habit of doing commits early and often. So we all kind of have this habit pre-autosave of hitting Control S every time you write something you don't want to lose if your computer shuts down. Just take that, apply it to Git. So I know like some people want to just commit a whole project at once. Personally, I think it's going to be better for people to just commit in increments and small increments, because it makes it easier to revert just a step or two at a time, and it makes sure that, nothing gets lost or is just this, like this vestigial organ of some other copy of your code is somewhere else. Like just start it early, get the repo set up at the beginning of the project. For those of you who are on this call because you want to learn how to start using Git with your projects, just push them in as is. Don't try to clean stuff up first and then do all of your, cleaning and organizing for Git after you've made a copy of it there. I think that's, going to help you figure out where stuff is and stuff won't get lost. So I did have a couple of examples. I've got the link here if anyone wants to go and look at. This is one that I published for Cache. But I just wanted to point out, so this is a visual of my local folder on the bottom right, and then my repo, and you'll see like I do have this data folder in where I'm working locally. I do all my editing locally. I very rarely actually edit in GitHub Online. But my data folder has all of the data that I'm working with right there, but that's not being tracked on my repo. And then as far as a README, so what goes into it? Anything relevant, really. But some of the stuff you definitely want to cover is like what the project is, what it's doing, any data sets you're using and where they came from, spatial and temporal extent of what you're trying to do, file navigation and how to use the code. So when people look at your repo, they understand what the folders are, what's going to be in them, what order to run things. You can include notes about any packages that people will need to have installed, any dependencies. Git will automatically note what programming language it was, but if you want to mention any other specific tools you use, you can add that there. And then just any other notes or background info that someone might need to take your project and run with it should be in there. And then just two more last minute recommendations. I personally find it easier to make the blank repository in GitHub first and then clone it to my local folder, partly because it makes sure nothing gets lost and I don't forget to set it up. Also partly so that my changes are all recorded incrementally, like I mentioned, but also because GitHub will guide you through setting up a lot of the documents you need. So like a README, you can just pick the format that matches your code editor and it's done. You can pick a license from a template that GitHub has and it's done. You don't have to figure out how to write it or what file format it needs to be. You can just pick those options when you set it up. And then when you clone into your local folder where you'll be doing all of your editing, all that stuff is right there. As far as the .git ignore, potentially a little bit more advanced to set this up, but if you make the repo on GitHub first and then clone it, you can just check the box. It will create one for you with a lot of default file types that mostly people don't want to track. So you'll have a lot of it there already. And then literally all I do is I go in and I type the word data and then a / in a line in that file, and then I save it. And then anything that's in a data folder in my working directory will not get tracked. So I highly recommend looking into that if you want to store your data in the same place as your scripts. And then lastly, even though you can do everything from the GUI or from web, like GitHub Desktop is fantastic. The integration with VS Code and RStudio is fantastic. Even if you're a beginner, I highly recommend getting familiar with at least like the very, very most basic Git command line functionality because it will help you understand what Git does before you're trying to go and figure out how to integrate with things that are remote and local and in different systems. So I linked a resource here that was super helpful for me as a very new beginner and someone who had never used Terminal before having to use it to set up Git. This will walk you through how to set it up, how to connect everything together, troubleshoot any connection issues. And honestly, like this was the most complicated part as a beginner was just figuring out how to make everything talk to each other. Because once it's set up, just pushing the buttons to commit things and typing your comments isn't that big of a deal. So highly recommend this resource. And that is all I have. Thank you.
I see we have a question from Audrey in the chat about whether we have resources for people who want to use Stata with GitHub. And I'm going to just let you all think about that for a second. While you do that, I'm going to just, I had a slide, a DOI slide. DOI is a digital object identifier. And it is a more permanent, it's at least a persistent URL rather than like an organizational URL. And so when you create a GitHub, you will get a URL, but that is not a DOI. And particularly the data sharing and management plans that Kevin mentioned, that NIH requires, they now are also require DOIs. So GitHub itself does not automatically generate a DOI for you. So I recommend that you can use Zenodo, which has a connection with GitHub. And if you use your org ID, then it is all connected. And then also Figshare, and Figshare is another place where you can get a DOI and connect it, though you have to do that manually. So so those are the options for getting a DOI, and DOIs are just one more way to make your work transparent and accessible to others. But just to echo many of the points Amy made, and also what to put in your README, as much as possible. Like, you really probably can't do, you will underestimate how much additional information is valuable to somebody else, and even yourself, if you go back to your own code, you know, some months or years down the line. So and remember, these are not necessarily a data dictionary or metadata. They're not all, those are all separate little pieces of this. So the transparency component, really how it's all collected, the translational piece is still in, you have to be sure you get it in whatever forms is necessary in part of the repo. I see Stata. Does anybody want to comment aloud about the Stata?
I agree with Amy, so I'm happy to just say what you wrote in there makes sense. So I don't use Stata. There may be integrations that are native to Stata, but even if there aren't, and with any situation where you don't have a native integration, GitHub Desktop works with any type of file structure. And so you can use GitHub Desktop to manage those things, those changes, and just work in Stata as you normally would.
Great. Thank you. So thanks. I'll start our conclusions. Thanks to everybody for coming. If you like this webinar and want more of it, or of this kind of thing, let us know. Part of what we're doing to serve the community of users, making these connections, making code more available, making it more transparent, making it more usable and collaborative across, you know, our various independent research groups. So we'd love to hear from you. Kevin, last words?
Yeah, thank you very much. For those that are following and tracking the CAFE educational resources, we're having webinars approximately every 2 weeks. So please check that out as you receive the newsletters. And if you have not gone over to Cache, I highly recommend you go over there. There's some beautiful tutorials already there. We learned a lot about Sheldis data from using their materials as well. So this will just be an excellent way to just enhance and expand the community's available resources. So thank you. And I want to thank all of our speakers for participating today, and Elaine and Nick for helping us get this set up. Everyone have a great week, and thank you for participating today.
Thanks, everybody. Bye.